Guys, everyone, please stay in the meet. We will be starting very soon. Okay, today we are discussing very important concept. So if you missed today's session, we couldn't re-explain you. And also, whatever today I'm gonna teach you, which is actually part of some other curriculum. Okay, so it is not there as per our schedule. So this is actually involved in higher PCB curriculum, but still I'm sharing the information. So everyone kindly join. I'm sending a reminder as well in the group. So we'll be starting the session within 5 minutes. Guys, kindly stay in the meet. We'll be starting within 5 minutes. Sri Krishna, okay, joined. Ibrahim not joined. Inamal, are you there? Okay. Inamal is there. My test. Okay. So how many of you know about gold finger? Gold fingers. Anyone having gold finger? Today our topic is gold finger. Karani, are you there? Okay. And who else? Akshay Karthik, are you there? Not there. Anurag, Astosh Kumar. I'm starting the live stream. Yeah. We are now live on YouTube. Vaibhav, you are the one with name Akshay Karthik, right?
No, I am Vaibhav.
Okay. Amarji, We will be beginning the session in 4 minutes, 7:25. Just stay for 4 minutes. We will start the session. So today's session is little bit important. So would be theoretical, but still it's important. Yeah. So right now, excluding me, there are 9 people, right? And excluding me and Varnit Gupta, okay, 8 people. So what happened to others? So today we will be discussing very important concepts. So today we'll be discussing about two different tests. Okay, in PCB, the PCB design is like all round. We need to discuss chemistry, we need to discuss physics, we need to discuss mathematics, isn't it? For formula derivation, we derived formulas, right? Let me check if YouTube stream is going on or not. Okay, fine, it's working. Yeah. So we derived formulas like standard with I mean track with formula. We derived impedance, characteristic impedance formula, isn't it? And we learned the chemistry behind chemistry about fire retardants like polybrominated uh, biphenyls, polybrominated diphenyl ethers, and we discussed about different compliances, ROHS, restriction of hazardous substances, environmental safety, consumer safety, right? And we discussed about the itching, isn't it? Chemistry behind itching. And from that we derived, we discussed about a comparison table among different etchants like ferric chloride, cupric chloride, HCl and H2O2, acid peroxide family, acid chlorides family, persulfates family like sodium persulfate, ammonium persulfate. So finally we come to a conclusion that cupric chloride is used as the standard etchant. Okay. So today we are discussing about something different, three different concepts. Okay, and there are two different tests. Okay, like one is rose test, ROSE, rose. Rose means not flower rose, so it's a different rose. We are having one rose test. So rose means resistivity of solvent extraction. Okay, rose means resistivity of solvent extraction. There is one test called rose test. Let me check if I have a PPT on it. Yeah, we have a something called rose test. So other than this curriculum, nowhere else you will be able to find information about these tests. Okay, you can find information in the online, but in a PCB design course, you nowhere else in online course you will find this rose test included in their curriculum. Okay, so this rose test is used to identify the cleanliness, how clean the PCB is. To identify the cleanliness of a PCB, rose test is performed. If someone asked you what's the one of the test, okay, use it to determine how clean the PCB is. So you need to answer it is rose test. So what is a rose? Rose, is it a flower? So how many of you guys do like a rose flower? You like it, isn't it? You like a rose flower, right? I don't believe someone really don't like a rose flower, isn't it? Everyone likes a rose flower. Yeah. So here the rose test means resistivity of solvent extraction. Okay, rose means resistivity of solvent extraction. So it is like a huge, there is something called IPC TM-650. Okay, IPC, here, here you can find that IPC TM-650. So there are different rules. Okay, in PCB design is not very simple as you think so. It is very complicated. So even we the people who expertised or mastered in them usually trigger into many mistakes. Even a small mistake can lead into something like a catastrophic failure, isn't it? So everything needs to be analyzed in the micro level. If you just think in the macro, you will not be able to know about detailed information. Always you need to start from the micro level. Everything needs to be analyzed in the micro level. So this is one such test called ROSE test. The main objective of the ROSE test is to determine how clean the module is, how clean the PCB is. Okay, this is usually performed after the assembly. Someone still joining late. Uh, so actually, I should not allow you as per the regulations because after 7:25 p.m. the meet should be logged. So Vishal, kindly please join in time. After 7:25 p.m. the meet will be logged. Okay, but I'm just not locking the session. But as per the rules, I need to log the session. I need to log the meet. So today we are discussing about ROSE test. So ROSE is not a flower. ROSE means resistivity of solvent extraction. The main object and principle of this test is to determine the cleanliness. It is also called as ROSE cleanliness test. Okay. So this is defined about this ROSE test is defined in IPC TM-650. This is one specification, one documentation where different tests are documented in that. If you are interested, you can go into that IPC TM-650. You can find more information over there. Okay. So in ROSE test, we will be using two things. One is the first one is isopropyl alcohol. So can someone just confirm me? Are you able to see my screen? Yeah. So in ROSE test, we will be using isopropyl alcohol. Okay, 75% isopropyl alcohol is used. Okay, so the organic proportion, see, this is the formula. There are something like uh, adipic acid. So how many of you know about adipic acid? Adipic, adipic acid. I'll show you. Adipic. See, the adipic acid is also known as hexane dioic acid. Okay, so why dioic? See, if you just check the structure of it, okay, just observe the structure of it. The total we are having 6 carbons. This is the carbon one, C1, C2, C3, C4, C5, and C6. Okay, so that's why hexa. And dioic acid, because we are having two carboxylic groups, COOH, COOH. So we are having two terminal carboxylic groups. Terminal, they are at the terminal position. Okay, I mean at the end of the chain or else begin. Okay, so if you consider this as the begin, this as the termination point. So we are having two carboxylic groups at two terminals at the end terminal points. So that's why this is known as hexane dioic acid. Okay, hexane, because it's not hexene because we are not having double bond, all are single bonds between all carbon atoms. We are having a single bond, so that's why hexane dioic acid, because two carboxylic groups. So since there are 6 carbons, it is hexa, it is ane, hexane, because we are having single bonds, no double bonds, and we are having two carboxylic groups on two terminals. So that's why it is dioic acid, because two carboxylic groups on two terminal position. So adipic acid is also known as hexane dioic acid. Okay. So this hexane dioic acid is used as a activator in soldering. It is used as activator in soldering. So what do you mean by activator? Any idea? Activator in soldering. Adipic acid is activator in soldering. So any idea what does activator mean?
which enables the reaction to proceed and make it faster to get
Yeah.
completed.
So actually what happens is whenever let's say you want to do some soldering, right? So usually when metal, okay, like a copper or whatever maybe, these metals when exposed to air, oxygen, so usually they have tendency to combine with oxygen and to form metal oxide bonds. Okay, metal oxides on the upper surface. So let's say if you are having some copper traces, if you expose it to oxygen for longer time, longer duration, so there is a possibility that on the top of the copper layer, the actual metal, a small, a tiny layer, okay, forms, a metal oxide layer forms on the top surface wherever it is exposed to the atmospheric oxygen or else atmosphere. So when this metal oxide layer is formed, so shouldering is difficult. Okay, metal oxide, when metal oxide is formed, shouldering is difficult. So we need to get rid of this metal oxide layer. To remove these metal oxide layer, this adipic acid is used as an activator which removes the metal oxide bondages, and therefore the bare metal. Okay, the bare metal, that means the main actual metal. Okay, will be exposed, and to that we can do the shouldering part. So that's why it is called as activator in shouldering. So, but the thing is, this is actually called as flux. Okay, this adipic acid is called as something like an activator. So these activators are used to remove the metal oxide layer to make soldering possible. But but the thing is, sometimes there would be remnant. That means additional adipic acid present. After cleaning the metal oxide bondages. So that thing should be cleaned. Okay, even the adipic acid should be cleaned. First, with the help of adipic acid, we need to clean the metal oxide layer, and then we need to clean the adipic acid as well, the excess adipic acid present on that. So sometimes the assembler, like who are performing these assembly, the assembly technician, so sometimes he may not be removing these kind of excessive fluxes used or else excessive activators. So it is very essential to remove that. So if this excessive thing is present, it is called as a contaminant. Okay, I mean it is also one kind of uh, unnecessary part. Okay, so we just need to use whatever that is necessary. Excessive fluxes should be removed. So this is also considered as a contaminant in ROS test. So to determine, see, to determine, this is actually poor practice. To make sure that the excess adipic acid should be removed. Using adipic acid is not a violation. Okay, so but excess thing should be removed. So if the excessive thing is present, that can be determined with the help of the ROS test. Okay, so in ROS test we will be using two things. One is the isopropyl alcohol. Okay, high isopropyl alcohol, and the another one is deionized water. 75% isopropyl alcohol and 25% H2O. Okay, yeah. And the next one is, see, I just gave you an example of adipic acid. Here another example is given in the PPT, which is abitic acid. Okay, which is one kind of another flux used. Okay, so I gave you the example of something like uh, adipic acid, which is used as an activator. So yeah, yeah. Here also example given like weak organic acids. Okay, weak organic acids are used as flux activators. Example, adipic acid. So that I just told you in a different word. Like adipic acid is an activator in shouldering. So these are called as flux activators. Okay. So these should be removed. Okay. So what actually they will do is like we are not going very in detail how this ROS test is performed. So we are just here to introduce you the terminology that these tests are existing. These tests do exist. What's their objective? What is the test? Which chemical is used? And what's the main objective of the test? That's it. We are not going in much detail and depth how these tests are performed and complete information about these particular specification IPC TM-650. So just a basic intro to IPC TM-650. Okay, just a basic intro. So we will be using isopropyl alcohol. That is very important. And these PCBs are, uh, yeah. So here the formula is also given. Total contamination. So the total contamination is actually determined in equivalence of sodium chloride. Okay, it is determined in equivalence of sodium chloride. Don't worry about all these things. It's not necessary. Okay, just to just tell you what are the things there. So the main objective of the ROS test is to determine what the cleanliness of the board. Okay, yeah. So there is one issue called electrochemical migration. Electrochemical migration. When ionic residues present under atmospheric humidity, they undergo a redox reaction under electric bias, spawning conductive copper dendrites. So actually there is something called electrochemical migration, okay, which is one of the issue. Okay, so many PCBs, when they are not dealt properly, they contain ionic contaminants on the top surface, I mean on the surface of the PCB. Okay, so they should be cleaned. Just we discussed earlier, like about ADP, no, adipic acid, hexane dioic acid, which is used as an activator in soldering. You can use it, but you need to remove the excess adipic acid. If it is not removed, then it may lead to something called as electrochemical migration issue. Okay, we will discuss a little more about ECM, electrochemical migration, in detail, maybe in some portion of this session, or else our course. So this ROS test is basically used to determine the ionic contaminants. Okay, ionic contaminants. And there is one more mechanism called ion chromatography. Okay, with the help of ionic chromatography also, you can determine the how clean the board is. You can determine that. So when ROS test is performed, if you yield high result, okay, so if you yield high result, so does it mean the board is very clean, or is it mean the board is not not clean? What do you think so? So should roast test yield high result, or should roast test yield you know low result? I mean, in the terms of a
Low
numerical
result.
value, it should yield a low result. If it yields high result, then it means you're having more number of contaminants and impurity. Okay, so always roast test should yield low result, not high result. So this is about a brief intro about a ROS test. So if you want to explore more information about resistivity of solvent extraction, so why it is called as ROS? So that is very essential, right? If I don't tell about ROS, why it is called as ROS test, and if I tell you we use isopropyl alcohol, it is used to determine ionic contaminants. Like I gave an example about adipic acid, which is an activator in soldering. So if it is not properly removed, okay, after utilizing the adipic acid for making the soldering easy by removing the metallic oxide uh, layers. So it is, but it is very basic. First, you need to understand why it is called as rose. Okay, so the rose, if you just understand the abbreviation rose, so resistivity of solvent extraction. The first term R refers to resistivity. Okay. So in as a isopropyl alcohol, when these contaminants, like it is actually not completely chemical procedure. It is actually called as physical dissolution process. This ROS method is not actually a complete chemical process. Okay, it's actually a physical dissolution process. Physical dissolution. So what do you mean by dissolution? These contaminants, like including the adipic acid or whatever maybe, so these contaminants like other fluxes and all these things, all ionic contaminants, they will be dissolved in the isopropyl alcohol. Okay, they will be dissolved in isopropyl alcohol. So when they are dissolved in the isopropyl alcohol, the resistivity changes. Okay, whenever you add something to the original substance, okay, whenever you turn the original substance into impure, the resistivity will also change because the matter is changed, right? So depending upon the the delta R, okay, how the R is changing, resistivity is changing. Based on that, in the solvent, okay, in the solvent extraction, I mean, whatever the solvent we are having, the extracted solvent, which contains the ionic impurities. So based on the how the resistivity is varying, based on that we can determine how much of impurity is present inside, how much of impurity is dissolved in the isopropyl alcohol. So based on this, we can able to determine if contaminant is less, the board is much cleaner. The contaminant is high. If roast test yields higher result, it means the board is not clean. Okay. Uh, so always we need to follow the cleanliness. Okay. Whatever the work we are doing, we need to follow cleanliness. So this is how. That's why the term ROS has been coined. Okay. R means resistivity of solvent extraction, ROSC, resistivity. Depending on how R is changing, we'll be able to determine the contaminants. Okay. So there may be something like a bromides or sulfates or a chlorides. So there may be so many uh, weak organic acids. Okay, adipic acid, which is also one weak organic acid. It is used as an activator. So all these things should be removed. Okay. Yeah. So this is about rose test. We are having one more test also, that is tape test. Tape. How is the term? Tape. Have you ever imagined before that there is something like a rose test that we can use to perform and to determine how clean the module, how clean the PCB is? That is about the rose test. So we are having one more test called tape test. I just don't know whether I have a PPT on tape test or not. Okay, I think I don't have a PPT on it, but still I will explain you about tape test. Yeah, up to here, any questions about rose test?
So like in roast test, we use isopropyl alcohol and deionized water, right? Like
Yeah,
that, do we have any other combinations or only they must be used?
only as of now, isopropyl alcohol and deionized water is used as a standard practice. That's why I told this is just a brief intro. If you want to dive deep into it, you need to go to that reference. Okay? That specific IPC TM-650, where it has been completely documented how this process to be executed by the uh, you know the manufacturers, and all its related information will be there. It's just to introduce you the term what is rose test. Okay. So as of now, isopropyl alcohol and deionized water, 75% IP and 25% deionized water is used as the standard practice. This is not the information that I am telling. It is as per the documentation, okay, which is provided by the IPC. So everyone follows the same rules, okay, no matter who is manufacturing the PCB, everyone should practice those rules. It is like a manual, okay, it is like a manual. And so the main objective of this rose test is to measure ionizable surface contaminants. Ionizable surface contaminants. What is the principle of rose test? So ROS means resistivity of solvent extraction. It evaluates cleanliness of a PCB. Okay, and it measures the ionizable surface contaminants. Okay, and yeah, this is about the ROS test. So there is some one more test called tape test. Okay, one more test called tape test. So before we jump into tape test, we need to first we need to learn about gold fingers. So how many of you want your fingers to be gold, made of gold? Anyone? Everyone, right? Everyone want golden finger. But here gold fingers in PCB is completely different. Might have never imagined that PCB is having gold fingers. Now I'll show you how PCB is having a gold finger. Okay. The section is going to be interesting today. And there is one more thing before I really explain you ENIG. Yeah, first I will show you gold fingers in PCB. Then I will show I will tell you about ENIG finish. Okay. Let me check if I have that page already. Yeah, here we go. I will show you the images first. See, have you ever seen any PCBs containing these kind of gold color fingers? Okay, extrusion, these kind of extrusion. So can you just name a few such examples where you have seen such kind of things? Anyone? There are many PCBs you might have seen. Desktop RAM. Yes, RAM contains gold fingers. Graphic cards. In graphic cards also, for PCB in graphic cards we have gold fingers, isn't it? You need to insert the PCB into the RAM slot, right? For RAM you need to insert into RAM slot. So yeah, RAM contains see, I'll show you. It is having small, very tiny gold fingers. I just don't know whether this image can be even further magnified, or else let me check for some high quality image. See, here we are having the gold fingers, right? These one. RAM contains gold fingers, network cards, sorry, graphic cards. See, see, you are able to observe that, observe, right? See, these are the gold fingers. See, these gold fingers enable us to, sometimes we may connect a CPU with many peripherals. So these gold fingers enables us to for faster communication, and to these should be designed in accordance with the slot. Okay, whatever the slot that you are having, there are different slots like PCI slots, isn't it? Those who might have any little bit idea about the hardware workshops like in computer, so there you will be learning about PCI slots. So yeah, so these should be designed in accordance with whatever the slot that you are having. Okay, that should be designed in accordance with that. So that is the gold finger. Okay, so we are having a little bit in detail about the gold finger. We will see. Yeah, someone is raising your hand. Yes, Sri Krishna.
Like if you observe some HDMI ports, there will be like two or three gold plated, right? Are there also the gold fingers?
HDMI.
Ports,
Okay.
connection ports. Like two in the bigger image, uh,
This one or this one? Are you talking about?
second
Second one.
one.
Okay.
Like if you observe
Yeah.
some gold plated like are there, right? At the below,
The
at the
below.
bottom.
You are talking about this one?
Below that one. Like some very small ejections are there.
No, no, no. Actually, there are different kinds of connectors. Okay. That is different aspect. That does not fall under gold finger. That's completely different aspect. It is not at all a gold finger. Okay. See, it is just a different kind of connector. Okay. That is not a gold finger. It is a different kind of connector. Okay. I can understand like what you are talking about. We are having something like a below something like a goldish appearance, right? So it is not actually part of gold finger,
Yes.
but yeah.
Okay.
So now we will discuss about in detail about gold fingers. Okay. So but before that, let me tell you something called ENIG finish. So actually there are two finishes. HASL finish. Whenever you are designing any PCB, the manufacturer usually gives you option to choose either HASL finish or ENIG finish. So first I will show you what is ENIG finish. Okay. So in ENIG, yeah, in ENIG finish, we will be using total three metals. Okay. We are using total three metals. So there is something called IPC 4552. Okay. IPC 4552. According to that, I am telling you. IPC 4552. Yeah. See, you can find as soon as I search it for IPC 4552, now I am getting the information about it. So IPC 4552 is the definitive industry standard for electroless nickel or immersion gold plating on a PCB printed circuit board. So there are two kinds of finishes. One is HASL finish. Okay, HASL finish. HASL means hot air solder leveling. Okay, hot air solder leveling. So whereas coming to ENIG finish, which means electroless nickel or immersion gold Okay. So according to IPC 4552, nickel should be, the thickness of the nickel. Basically, we are having copper traces, right, on the top surface and on the, if you are working on a board, two-layered PCB, so we can find copper traces on the top copper layer and the bottom copper layer. So these copper traces, basically they're made up of copper, as far as you know. Okay, but actually, uh, copper traces are not completely made up of copper. We use two different methods like HASL method and ENIG method. Okay, electroless nickel immersion gold method, in which we will be using two more additional metals on the top surface, just like as you're having a copper track. Along with the copper, basically we are having a sandwich of three materials for making the traces on the copper. We are having sandwich of three metals. Okay, three materials, three substances. The first one is copper. That is by default it is the conductor. Okay, good conductive material. And then above the copper we will be having cobalt. Okay, above that we will be sorry, we are having nickel. Okay, we are having nickel. Cobalt is also used. Cobalt is used in gold fingers. In gold fingers we will use something like a little bit percentage of cobalt also. So around 5 to 10% of cobalt is used. So why cobalt is used in gold fingers? Because cobalt increases rigidity. Okay, cobalt increases rigidity. So that's why 5 to 10% of cobalt is used along with in gold fingers. Around 5 to 10% of cobalt is used. Okay, so this uh, uh, you know ENIG method is very expensive. Okay, very expensive. So do you think real gold is used or gold plating is used? What do you think so? Just a gold color or is it real gold? Any idea? Anyone?
I think it's gold plated because if they
So
use a real
see,
gold,
many people will have a two thing like two different opinions. So those who think it is not real gold, please raise your hand. Those who think it is not real gold. Okay, okay, yeah. Anyone? Anyone else? So okay. So everyone think it is gold. Okay, okay. So those who don't believe it is real gold, we have three members. Rest all believe it is real gold. You think so? Everyone. Others who not raised the hand, you think it is real gold? Okay. So I'm just lowering your hand as of now. So one thing I would like to let you know is it is real gold. Okay. It is real gold. Real gold is used. Okay. Real gold is used. So that's why it is very expensive. So in ENIG method, okay, electroless nickel method. So real gold is used. So if you just ask the Google, okay, it will give you the answer. Is real gold used in ENIG? Electroless immersion gold. Yes, real gold is used in ENIG. Okay, it is not just coloring. It's not just gold color. Real gold is used. So already we discussed in one case study, right, in China. So where we discussed that they are used to extract very expensive materials from PCB, like silver, gold. I mentioned gold in that session. If you want, you can go back and check that session. There you will find along with gold, silver also I mentioned. Silver is also used. Okay, but not in this specific method. Maybe in different aspect it may be used. So many expensive metals can be used in PCBs. Okay, so real gold is used in electroless, ENIG, electroless nickel immersion gold method. Okay, so now we will be discussing. You see, if a real gold is used, so we also need to analyze what should be the thickness of different metals that are used. This is very essential to understand because no one don't know about it. Okay, so no PCB designer existing right now don't know about this information. So this is according to IPC 4552 specification. The thickness of the nickel should be 2.54 micrometer to 6.35 micrometer. It should be 2.54 micrometer to 6.35 micrometer. Just remember 2.54 micrometer to 6.35 micrometer. And I told gold is also used, which is actually called as immersion gold. Okay. So this immersion gold, the thickness of the immersion gold should be 0.0508 to 0.2032 micrometer. 0.0508. Okay, I'm posting in the chat box also for your reference. So gold, it should be 0. Something like 0.0508 to something like 0.203. Okay, it is in micrometer. Okay, so 0.0508 to 0.203 micrometer thickness of gold is used. Coming to the nickel, around something like a 2.54 micrometer to 6.35 or something like a 6.33 or 6.35 micrometer. So this is the information as we we have been working on PCBs since very long. We at Suchna have been delivering a customized PCBs for many companies, from with custom silk screens. So starting from schematics all the way up to footprint symbols, we designed custom symbols, custom libraries are there. We have our own libraries, footprint libraries, symbols library. So as far as we have the information, the complete information which is available at Suchna, our dedicated team. So this is the according to IPC 4552 specification. The thickness of the nickel should be 2.54 micrometer to 6.35 micrometer. So now the question is, can I put greater than 6.35 micrometer? Isn't it? So is it possible? Can we put the thickness of the nickel greater than 6.35 micrometer? No, you are not allowed to put the thickness of the nickel greater than 6.35 micrometer. It should be less than 6.35 and should be greater than or equal to 6.54, less than or equal to 6.35 micrometer. You are not allowed to put even 6.36. Okay, it should be less than or equal to 6.35. So, and next coming to the immersion gold, the thickness of the gold should be 0.0508 micrometer to 0.20. I have mentioned up to 3 decimals here, but it should be like 0.2032. Okay, the lower level, I mean the maximum threshold, max threshold, yeah, the max threshold allowed thickness for gold. Okay, arm gold is 0.2032 um. So you cannot put greater than 0.2032. If you put 0.2033, it is an error. You are not allowed. Okay. So it should be 0 greater than or equal to 0.05 and should be less than or equal to, it should be greater than or equal to 0.0508 and should be less than 0.2032 micrometer for gold. And coming to the standard ranges, these are actually specified. Whatever the values that I told you right now, these are actually specified in IPC 4552 specification. But everyone, on the standard practice, they use a standard range. For nickel, many manufacturers, including we use thickness of 4 to 7 micrometer. Okay, for nickel, we use 4 to 7 micrometer. See, whatever the range that I'm telling you, 4 to 7, it falls under the range which is specified by the IPC 4552, isn't it? 4 to 7, it falls under 2.54 micrometer. It is greater than 4 and 7. Both are, see, actually, I am telling you the 7, but actually, the 7 many people are using, but it is actually not allowed. So it should be something like 4 to 6.35, but many people rounded it off and they started using 7 micrometer. Okay, but as days passing by, this became a standard range. See, actually, according to IPC 4552, it is specified that it should be within 2.54 micrometer to 6.35 micrometer. But as time passing by, people started rounding it off 6.35. They rounded it to 7 micrometer, and they started using 7 micrometer as well in some situations, in some scenarios. and thus the standard range become 4 to 7 micrometer. It is not no more no more 6.35. Some people are using 7 as well. So they've chosen a standard range 4 to 7. But we at Suchna always we make a PCBs of range 4 to 6.35 only. Okay, 4 to 6.35. So we never go beyond 6.35 because we strictly follow. So we are actually having a little bit value higher than 2.54, that is 4. So sometimes we may use 2.54 as well, depending upon the scenarios, depending upon the situation. But usually the range that we follow is 4 to 6.35. But actually the standard range is 4 to 7 because 7 also becomes standardized. Okay. And coming to the standard ranges of gold, immersion gold, it is 0.05 to 0. Something like 28, 0.28. According to specification, it should be 0.2032. IPC 4552, it should be 0.2032. But people will be using something like 0.05 to 0.28 micrometer. Okay. Yeah. And yeah, this is about the detail. And then now we will see about, uh, you know, how many of you learnt about something like expansion of solids? Might have studied expansion of solids, liquids, and gases in your physics, right? Maybe in your grade 12 or grade 11, something like that. How many of you studied about expansion of solids, liquids, and gases? So in that we are having a formula. So I just don't know you remember that or not. Alpha is equal to delta L by L by delta T. Or else first I'll tell you the simple formula. Delta L by L is equal to alpha delta T. Okay, I'll show you the formula. Expansion of solids, alpha formula. Here alpha is called as coefficient of thermal expansion, CTA, coefficient of thermal expansion. Yeah, this formula is derived from that formula only. Delta L by L is equal to uh, alpha delta T. Yeah, this is the main formula. So this formula, where alpha is called as coefficient of linear thermal expansion. Formula is for linear thermal expansion. Delta L by L, because we are having volumetric expansion, isn't it? Linear length can be increased, volume also changes. Okay, so delta L by L is equal to alpha delta T. So from this equation we can understand that. So the rate of change, sorry, the when the length is varying, okay, delta, uh, the difference in original length. Now whenever we heat any metal, any solid, usually it is having a property, when it is heated it expands, and when it is cooled it is having a property to contract. Okay, when heated it usually expands. So when it expands the length is increased. Okay, of course there is change in volume also changes, length changes. Okay, there is something like called a shearing. We learnt all these things. So here if we consider length, okay, if you just consider about linear expansion, uh, usually when heated the length increases. So the final length minus initial length, which is called as delta L. Where L is the origin, let's assume delta L is equal to L final minus L initial, where L initial is the original length. L final is the length which is due to heat the length has been increased. Okay, so the difference in final length to original length we call it as delta L. So the change in length is proportional to the applied temperature. Okay, the change in length is proportional to change in temperature, and it is inversely proportional to the original length. So from that, actually delta L is directly proportional to delta T, and or else delta T is directly proportional to delta L, and delta T is inversely proportional to L. Okay, so from that they came to one thing called delta T is directly proportional to delta L by L. By removing the proportionality, we need to put a proportionality constant, that is alpha. That's how the alpha has been discovered. Okay, delta L by L is equal to alpha delta T. So if you put alpha on one side and you bring delta T on the another side, so finally you will be having the formula for alpha. Alpha is equal to delta L by L by delta T. So now why we are discussing this particular thing is these three metals. See, there is one example also provided when your lecturers are telling about this thermal expansion. So where two metals are connected with each other. Okay, on one metal, another, if you put another metal, both are having different thermal expansions, isn't it? So that has been a few examples, few questions would have been asked in JE as well. So similarly, here we are having three different metals. First one is copper. Okay. So do you know what is the alpha value for copper? Any idea, anyone? So copper is actually having something like 16.5 into 10 to the power of minus 6 by 16.5 into 10 to the power of minus 6 per degree centigrade. Okay. Usually, see, for all the values, I'm just telling you in reference 16. I mean, whatever the values that I'm going to tell you right now, the alpha values for copper, nickel, and gold. So all these values are something like whatever the value I'm telling, you need to multiply it with into 10 to the power of minus 6 per degree centigrade. Okay, I'm just excluding 10 to the power of minus 6 right now. So for copper, it is like 16.5 to 7. Okay, it means 16.5 into 10 to the power of minus 6, 10 to the power of minus 6 by per degree centigrade, and 17 into 10 to the power of minus 6 per degree centigrade. For nickel, it is 13. For gold, it is 14.2. Okay, for copper, I will show you in as well. Alpha coefficient, yeah, CTE, coefficient of thermal expansion, CTE of copper. Usually in between, see, the coefficient of thermal expansion, CTE of copper is approximately 16.5 into 10 to the power of minus 6 meter per degree centigrade. Okay, I mean per degree centigrade. That means this much of alpha it is having. So that means for 1 degree rise in temperature, okay, delta L by L by delta T, right? So that's why in the denominator we are having per degree centigrade. Okay, numerator no unit actually. Okay, because delta L by L both are length, right? So unit get cancelled. Finally, you will get per degree centigrade. So that's why here also he given meter in both numerator and denominator. Meter get cancelled. Finally, you will be left with 16.5 into 10 to the power of minus 6 per degree centigrade. Okay, and then uh, you know usually it is 16.5, but sometimes it can, it also varies. The alpha level value varies with respect to temperature, the room temperature. So usually at room temperature it is 16.5, but it can be up to 17, 16.5 to 17. That's why I told you the range, 0.5 to 17. 1 meter. See, if you convert this 16 into particular thing into ppm, like if you just exclude 10 to the power of minus 6, you need to call it as ppm. Okay, parts per million. So that means 16.5 parts per million per degree centigrade. Okay, so that means 1 meter. If you this means a 1 meter piece of copper will expand by 16.5 micrometer for every 1 degree rise in temperature. So for every 1 degree centigrade rise in temperature, 16.5 micrometer expansion would happen for copper. Okay, 16.5 micrometer expansion. It will expand by 16.5 micrometer. That means this is extra length. Okay, so the original length would be minus whatever the length final, L final minus 16.5 micrometer. That would be the original copper length. Okay. So similarly for nickel, we will be having 13 into 10 power minus 6. That means 13 ppm per degree centigrade. And for gold, it is 14.2. You can also check the values as well. So for pure gold, the linear coefficient of thermal expansion is approximately 14.2 into 10 to the power of minus 6. The values are the values are very similar with whatever we have at Suchna, okay, as per our Suchna documentations. So for copper 16.5 to 17 ppm, and for nickel 13, for gold it is 14.2. Okay, so different materials is having different coefficient of linear coefficient of thermal expansion, CTE. So now I will show you one image about ENIG finish, so then you can understand very easily about it. Okay, I will show you the images. We are having that images as well. If you just search in the Google, you will get that those images. See, if you just observe these images, so earlier we discussed that this is the FR4 material. Okay, see, FR4 material will also have a linear thermal, a linear thermal coefficient of expansion, linear coefficient of thermal expansion, CTE. For FR4 material also, it would be some alpha value will be existing. You can find that alpha value of FR4 material as well, because every material will have a coefficient of thermal expansion. Okay, yeah. So see, earlier we discussed that above the FR4 material we are having copper traces. Now what we are discussing, so above copper we are having other layers also. So not just a copper, it is a sandwich of three materials. So if you just check, the bottom material is copper pad, okay, the actual copper track, and above the copper we are having nickel. So and above the nickel we are having gold. Okay. So here gold thickness it is mentioned as 1 to 5 micro inches, right? But what actually I told you? Anyone remember what's the value that I told you? The gold thickness. Anyone?
Zero point
0.00508.
0.052.
Yeah. So 0.05082 to 0.2032 micrometer. That's what I told. So now it is given in micro inches. Okay. What I told you is in micrometer. So now I will tell you one formula like for conversion of micrometers into micro inches. So 1 micro inch is equal to 0.0254. Okay, I will post here. So 0.1 micrometer is equal to 1 micrometer to 1 micro inch equal to 0.0254 micro inches. 1 micrometers. 1 micro inch is equal to 0.0254 micrometer. Okay. Now for gold, what I have told you, 0.0508. 0.0508. Now we need to convert it into micro inches. You want to convert it into micro inches. Now what you need to do? You need to multiply this particular number with 0.0508. So I will, so that you can, because for use 0.02 micro inches. This is the formula that I told you. Okay. 1 micro inch is equal to 0.0254 micrometer. Okay. So if 1 micro inch is equal to 0.0254 micrometer, then we need to find, so 1 micro inch is equal to 0.0254 micrometer. Then this much micrometer is equal to how many micro inches that we need to find. Okay. So to calculate that, you can substitute in this formula, you will get the value. Okay. So we are calculating it. we got 2 micro inches. Okay, we got 2 micro inches. 1 micro inch is equal to 0.0254 micrometer. Then 1 micrometer equal to how much? 1 micrometer equal to 1 by 0.0254 micro inches. Okay, so 1 micrometer equal to 1 by 0.0254 micro inches. Then this much of micrometer equal to how many inches? So that means 0.0508 into 1 by 0.00254. You need to divide this particular number, this number 0.0254. Then you will get in micro inches. So from that you got 2 micro inches. Okay. So and next, what's the upper threshold, max threshold value that I told? The upper one is 0.2032. 0.2032. So now I'll do one thing. 0.2032 divided by 0.0254. So we are getting 8. So from this it can be in something in between 2 to 8. Okay, 2 to 8. So that's the actual value according to the specification, 2 to 8 micro inches. So here it is given 125 micro inch. 125, it is 2 to 8. So 125 is also used. 125 is also used. I told you, like, those are the actual specifications, but industrial practices are different. Industrial practices are different. Okay. So if I put now one more thing, now we will calculate for nickel. For nickel, I told you it is 2.54 micrometers. Now if we convert 2.54 micrometers into 2.54 micro inch, so I'm just replacing the upper value, 2.54 micrometer, 100 micro inches. For cobalt, sorry, for nickel, he mentioned properly. Thickness is 100 micro inches. And the upper value he mentioned 200. Let's verify with value. For the upper, the max threshold that I told you, the thickness according to IPC 4552, it is 6.35. Max allowed thickness of copper, 6.35 micrometer. So if you convert that, you are getting 250. So here it is mentioned 200 micro inches. So for gold, we got 2 to 8 micro inch. For nickel, we got 100 to 250 micro inches. But the actual implementation, like, is little bit varying. It is little bit deviating from the actual specification. I don't reject whatever the values here is specified. See, for nickel, it is within limit. Okay. So if you reduce 5 micro inch thickness, okay, it's perfectly 100 to 200. This is very good. This range is very good. Gold is also very good. Okay, 1 to 5. So no need to put that much of micro inch thickness. Not necessary. So that is as per the specification, but range would be little bit different. Okay. So this is about this is how the copper traces are built. So earlier you thought, well, whenever we are having any copper trace on PCB, you thought only it's a copper layer. But now what we discussed, what we revealed today, it is not just a copper layer. It is a sandwich of 3 materials. One is copper pad, nickel, and the gold. So this is about this is called as ENIG. Okay, electroless, nickel. What is the full form of ENIG? No one remember that. It's very essential. Now I'll ask question. What is the full form of rose? Can someone tell me what is the full form of rose? I'll ask randomly one person. Let me check. How well you remember the full form of rose? Are you there? Or else are you busy with your class? Nihal Reddy, are you there? What is the full form of rose?
Resistivity of solvent extraction.
Perfect. So Vaibhav, now can you tell me what's the full form of ENIG?
What?
What is the full form of ENIG?
ENIG.
Just now we discussed the metal, right? We are having a 3 metal layers, not just a copper track. Above copper, we are having nickel. Above nickel, we are having gold.
Yes. Electroless nickel immersion gold.
Perfect. Only you need to remember electrolysis and immersion. Okay.
Okay.
You know about nickel because the nickel material is used, and gold. ENIG, G means gold. Electrolysis, nickel, immersion, gold. Only need to remember electrolysis and immersion.
Okay.
This is ENIG, electrolysis, nickel, immersion, gold method. So is it clear up to here? So if it is clear, now we need to discuss one more test called as tape test. Everything is clear. So I hope everything is clear. You can just quickly press the thumb, use the thumb emoji. Just give a small reaction so that I can proceed further. Everyone, those who understand today concept, rose test, ENIG method, electrolysis, nickel, immersion, gold, activity of a solvent extraction test, and we discussed about the copper, nickel, and the gold, their values, their thicknesses, IPC 4552 specification, what is standard ranges, so how it is deviating from the actual values to the when we come into industrial application. We discussed about linear coefficient of thermal expansion for different materials, copper, nickel, gold, and we discussed the formula alpha is equal to delta by delta. Okay. So since see this nickel layer which is present on the upper surface of a copper layer, so you know there is something called as you know this actually the thickness of the gold is very negligible. If you just check the thickness of the gold layer, it is very negligible. Why is this clear now? Is this clear? Yeah. So the thickness of the gold layer is very negligible because you are having 0.0508 to 0.2032 micrometer only. Okay, that means very small. So around 2 to 8 micro inches or else 1 to 5 micro inches. But in industry, like the values would be little bit deviating from the actual specifications. So the thickness of gold is very small, very negligible, so that it can cope up with different materials are having different coefficient of thermal expansion, right? So it can cope up with that because the thickness, whatever that we are using, is very small. So it is very minute. It is very negligible. So now we will go into something called as tape test. Okay, how many of you are interested to know about tape test? Tape test. We discussed rose test. Do everyone like the rose test, or are you hesitating that? React with thumbs so that I can proceed. We like the rose test. Now we are discussing about tape test. So before discussing about tape test, we need to discuss about one company. The company name is W3 or 3W. Let me check. So it is 3M company. Okay, 3M company. See, this is the website of 3M company. You can uh, find more information in Wikipedia as well. So this 3M company is actually where 3Ms refers to one first M refers to Minnesota, and second Minnesota, second M refers to mining, and third M refers to manufacturing. Yeah, here it is mentioned. Minnesota, okay, Minnesota Mining and Manufacturing Company. So this is actually an American multinational company. It is American based company, and there is something called Fortune 500. Okay, Fortune 500. So in Fortune 500 top companies which are having high sales, okay, high turnover in revenue, they are usually listed in Fortune 500 list. So this 3M company has been listed in Fortune 500. It is into as per Fortune 500 2021 rankings. So its position is 102. Okay, so it achieved 102 position in Fortune 500 list, which is published in 2021. So its turnover is something like, it's a sale, okay, 35.4 billion, okay. And as of now, according to recent statistics, it is having 95K employees, and it is operating, this 3M company is operating in 90 plus countries. It is operational in 90 plus countries. So in different countries, they established different units. Like in India, we are having 3M India, and in Japan, 3M Japan, and 3M different, in different countries they are having different subsidiary, like their bodies. Okay, operational in 70 plus countries, around 95K plus employees, and it got ranked 102 in Fortune 500 in 2021 rankings. So why we need to discuss about this particular company? Okay, what's the relation with this 3M company with our tape test in PCB? So yeah, I'll show you. Yeah, here it is mentioned. Whatever the information that I told you, it is also available in Wikipedia. 3M made 35.4 billion in total sales in 2021 and ranked member 102 position in the Fortune 500 list of the largest United States corporations by total revenue. So as of 2021, the company had approximately 95,000 employees. That's what I told, 95K employees, 95K plus employees, approximately 95,000 employees. Operations operations in more than 70 countries, 70 plus countries. There are a few international subsidiaries such as 3M India, 3M Japan, and 3M Canada. Okay. So here we are having the complete information about this particular company. And one thing here we need to discuss is like in June 13, 1902. Okay, in June 13, 1902, the company, the birth of the company, sorry, the first sale of the company took place. Okay, the first sale of the company took place in June 13, 1902. And the main goal of this company during that time was to establish a mine for corundum. So you know about corundum? Corundum mineral. We discussed in extraction of ores and extraction and purification of ores in metallurgical processes. In organic chemistry, it came. So corundum is basically an aluminium crystalline salt. Okay, aluminium crystalline substance. Al2O3, corundum. Corundum is a crystalline form of aluminium oxide, typically containing traces of iron, titanium, vanadium, and chromium. So their percentages also available. So I'm not going into that much of detail. So this corundum is a crystalline form of aluminium oxide, Al2O3. Okay, aluminium crystalline salt. Form of it's basically a crystalline form of Al2O3, which we know about Al2O3, but the same Al2O3 in crystalline form, when it is mixed with some other in mineral, like different kinds of substances that I shown you. So it basically, it is called as corundum, and which was failed. They tried to establish something like a mine for corundum, a crystalline form of aluminum oxide, but it failed. Because what they found, they actually tried to extract corundum, but what they got is anorthosite and feldspar. Okay, anorthosite is like a tri-aluminum silicate, I think so. Let me check. Yeah, feldspar, I think. Yeah, feldspar is tri-aluminum silicate. Yeah, aluminum tectosilicate. Yeah, it's aluminum tectosilicate. So this is the feldspar. So these are actually, they have low commercial value. Okay, they won't hold high commercial value. Like they're a little bit cheaper than what they are actually trying to mine for corundum. So later this company moved into St. Paul in 1910 and remained for 52 years before outgrowing the campus. So they later in 1947 they started producing perfluorooctanoic acid, PFOA, perfluorooctanoic acid. So which is actually a surfactant. So even inside our body, for our respiratory system to function properly, there are some natural surfactants. So these surfactants are something like a lubricants. Even our body also, we are having surfactant, natural surfactant. So this is like artificial surfactant. Okay. So this perfluorooctanoic acid, which is an industrial surfactant. So finally, they started producing so many asthma inhalers, and they worked on many kind of things. So So coming to the relation with our thing is like they produce something called as 3M tapes. Okay. Just to tell you 3M tapes, I told you this much of information because this 3M tape has been widely used. So if you just search for 3M tape, you will get so many tapes. 3M tapes. See, 3M tapes. 3mindia.in, their official website. Okay, 3M tapes. All these are different kinds of tapes. So these 3M tapes are used to perform tape test. Okay, tape test. So I will show you about a tape test as well. So by explaining the tape test in very brief, I'm not going much in detail. Okay, I will explain you about tape test in very brief. But before that, rather than making the things little bit messy for you, first I will explain you one interesting thing, like one thing. Then we will go into tape test. Okay. First we discussed about today. We started the session by discussing about rose test because everyone like roses, and then we discussed about uh, gold fingers, and then we discussed about the 3M company, uh, and then now we are discussing about what are the different kinds of gold fingers. Okay, there are different kinds. The first one is regular or flush. There are different types. I will show you. There are different types. I just don't know where this information is available. I'm just checking if there's any information available on this particular thing. Okay, if no information available, I will directly search for an image and I'll show you. The first one is regular or flux type, flush type. Okay, flush type or flush type or regular gold fingers. Yeah. So these flush type or gold, regular or flush type gold fingers, you find it in graphic cards. Okay, whatever you are having in graphic cards, they're actually called as uh, flush or regular type. Okay, they have an even continuous array of rectangular pads. So all pads are having same length. Okay, all pads have same length. All are ideal. All are continuous array of rectangular pads. Everything is even. So, but whereas there is one more thing called as segmented or intermittent. Segmented or intermittent. First one is regular or flush. Second one is segmented or intermittent. Segment gold fingers. So segmented means divided, right? See, this is the segmented one. See, this is what we discussed about ENIG, electroless nickel immersion gold. Okay. See, there are different types of gold fingers, right? So the first one is like here we are one kind of gold finger is showing, which is non-uniform. Okay, they are non-uniform. So they are also called as uneven gold fingers or non-uniform gold fingers or else long shot gold fingers. Why it is called as long shot? So one is little bit longer and another one is shorter, longer, shorter, like that. So this is uneven or else non-uniform, non-uniform or uneven or else long shot gold fingers. And second one is segmented. Okay, the gold fingers have a segment. See, segmented over here, two segments. This is segment A, segment B, fragment A, fragment B. So two partitions. So that's why this is called as segmented gold fingers. And next one is long shot. These long shot are uneven. Long shot are uneven. These are actually used in USB drivers. You are having USB drivers, right? So just check that USB drivers. You will find long shot gold fingers in USB drivers, card readers. memory related modules. Usually these are used in memory applications. Whereas these segmented are also used little bit, rarely these are used segmented, and they are also having some important applications. So see, this is the PCB substrate. This is the gold finger. You know how, sorry, this is the copper track. You know how these copper tracks are made, right? We discussed the procedure, etching, chemistry behind etching, and how these copper tracks are formed. First, they apply photoresist, exposure to UV material, isn't it? Dissolution of unnecessary copper, which we call it as the etching process. So above these copper tracks, these nickel, and above the nickel, gold is plated. Okay, this is the ENIG procedure. So actually ENIG is not only the procedure, we are see this ENIG procedure is also called as soft gold. Okay, ENIG is also called as soft gold. There is one more procedure called as hard gold procedure, where directly the gold is electroplated, okay, which is expensive. Okay, so ENIG is the standard practice rather than the hard gold. ENIG is the standard practice. So here also dimension, I mean thicknesses are given, micro inches. In micro inches it is given 150 to 200 micro inches. So what we discussed is 100 to 250 micro inches, which is the actual method, actual values which are prescribed in IPC specifications. So see, different people are, they are, giving different values. So what I gave you is a standard value. That is the complete truth. Okay, what the information that I told you is complete truth. Yeah. So this is about ENIG and different kinds of. This is the segmented or intermittent. This is segmented or intermittent. This is non-uniform or else uneven or else long short type. And if if the same non-uniform kind of thing, if this one is also uniform, like everything is even and identical, then it is called as regular or flush type, which are found in graphic cards. Okay, I'm just checking if the stream is still going on. Okay, fine, stream going on. Let me check in YouTube Studio, because if stream fails, fortunately stream is going on. That's great. So this is about today's session. Now coming to tape test. Okay, this is the last topic. So whatever today I told you, so many topics. So actually this should be covered in one. Actually we need to take so many days to cover this. But I'm just I don't want to waste your time by taking so many sessions. So time is valuable. So I'm just telling you all the things in such a way you will be able to understand very easily. Okay, tape test. Just like segmented, intermittent, flush or regular, or else what's the other one that we have? uh, Long shot or uneven. So keeping this thing aside, there is no even topic allocated for gold fingers. So unfortunately, today we also discussed about ENIG procedure, which is also not part of our curriculum. Okay. So usually in this curriculum, we only reveal that we use copper tracks. So if you opt in for higher course, then during that course, we will reveal that we not only use copper, we use combination of three materials. We use copper, we use nickel, we use gold, and it is real gold. And we will reveal the thicknesses in the actual higher sessions. But I gave you the information. Okay. Yeah. So coming to the tape test, uh, there are so many tape tests you need to specify in PCB, or else you will get different things. Yeah. In PCB manufacturing, a tape test is a quality control method used to evaluate the addition. Okay, which means two substances are, when we are having three materials in contact with each other, right? Which we call it as addition. Okay, so addition means in touch with each other, in contact with each other. So how strong they are, how strong these three materials, copper, nickel, and gold, how strongly they are connected with each other. Okay, the adhesion force, how strongly exhibited between them, that can be tested with the help of tape test. So basically, see, it's a very, the name is difficult, but the actual procedure is simple. So here we are having gold fingers. On the top of the gold fingers, he's applying some tape. This tape is nothing but W3, 3M tape. So that's why I told you about 3M company. Okay. So they apply this 3M tape and they will remove it. Okay. With a little bit force. So if gold is sticking with the tape, then it means the adhesive forces between the gold and the nickel is not very strong. That means it is failing the quality control. Okay, the piece is treated as QC failed. QC means quality control failed. So no gold is allowed to stick with this particular tape, 3M tape. Okay, so that's very simple. Just apply tape and drag it. If gold is sticking with the tape, 3M tape, then it is failed in uh, quality control. Okay, so today we discussed about the chemistry of the rose cleanliness test, rose test, isopropyl alcohol, how these uh, flux activators like adipic acid, how these are removed. So all these things we discussed. Okay, there are a few issues like electrochemical uh, migration issues. So if you do not remove the fluxes, we will get these kind of issues. So what are those issues? That thing we will discuss in the upcoming session. So this is the global standard for PCB testing methods. Okay. So all these rows tests came into the picture of 1960s. Okay. So there is some specification called TM-650. So this TM-650 came in the year like all these things happened. See, earlier during 1960s, there is no specific method through which we can assess the quality of a PCB. Different manufacturers have their own test. I am a PCB manufacturer. I have my own test to assess the PCB quality. You are one manufacturer. You have your own test. So different people, different companies have different tests. So once this TM for 650 and other IPC specifications like IPC TM 650 and IPC 4550, all these things, when they came into the picture, then people standardized. Okay, the quality control mechanisms for a PCB got standardized. So now everyone is following same methods, same tests, rows test, tape test, like this. There are many tests. Okay, not just one or two. There are so many tests like that. I'm just telling you two examples out of so many tests. See, this is the rows test, which is mentioned method 2.3.25 in IPC TM650 specification. And there is one more method called ion chromatography method 2.3.28. So like this, the tests become standardized. So by this, the signal integrity has been increased. Yeah, so this is about today's session. So we discussed about the quality control methods, especially rows test, resistivity of uh, solution extraction, resistivity of solution extraction, and then tape test. We discussed about 3M tapes, about the 3M company and its history. And I hope today's session is very informative for you. So I bet that other than this course, nowhere else in any online course you will be able to find this information. So just very rapidly give some reaction with your emojis before I end up the session. If everyone gives reaction, then it will be energetic. Rapidly, everyone. I want thumbs, anything that you want. Rapidly, everyone give emojis. Keep on doing. Perfect. So I hope today's session is informative. So if you like today's session, go, yeah, one more announcement. So those who want a certificate of completion from our Suchna space and GrowIota logo will be there. So there are two templates available. One is basic template where there will be logo but no signature of me, the mentor, and no signature from GrowIota. So just a basic template which will be delivered very immediately. So it is not having that much of work, but still those who cannot afford a premium template, they can go with the basic one. Those who want a premium template, a small processing fee would be there. The payment procedure, whether it should be through Razorpay payment gateway or through any QR as you did earlier. So that will be informed by the sales team and administration department. So what's the fee and how to pay and what's the last date? A circular will be released. So it is mentioned that by tonight, a form will be provided to you. But as per the recent communication that I got from the admin team, so due to some technical issues, today unable to provide the Google Form link. So max by tomorrow morning, you will have a Google Form link. And moreover, tomorrow there is no PCB session because today I told you 3 days session actually. Okay, 3 topics it should be taught in 3 sessions, but I told you in one day. So tomorrow there is no class. So tomorrow at that time, you complete the form. Okay. So and what is the today date? What's the today day? It's Saturday. Yeah, already Sunday. Tomorrow no session. Weekends there is no session. Already as per the schedule also no session. Okay. Yeah. So Monday I will be on leave. So again on Tuesday we will be having one quiz session. So after the quiz session we will be discussing about uh, you know 1 or 2 concepts which are left over. After that the PCB design classes are over. So your last session is on Tuesday. Sunday is holiday, and Monday, if possible, I will take class or else no class. So Tuesday is the last working day, and then on Tuesday we'll be discussing all the leftover topics. Around 2 or 3 topics are left over. Okay, and we will discuss that. So then after, you will be having few programs like a graduation program, and a few programs are there like how you can involve in the Suchna activities, how to get involved, and how to join our community. That will be informed. There would be a small program and you can join that program only for your batch. Okay, for every batch we have different program. So for your batch there would be a graduation program. So by tomorrow evening I want everyone to submit the form. Okay, so I suggest you to go with the premium template because that certificate can be posted in social media, in LinkedIn, in all the, we will provide you a verifiable credential. So the certificate can be verified. A verifiable credential will be there. Our logos, premium template, and a small examination would be conducted on Wednesday. And it's an online proctor exam. So we will monitor you. You need to turn on your cameras and you need to write the exam. So everyone will be monitored. For each and every 2 people, one uh, moderator will be there. So you'll be monitoring the examination. You need to turn on your camera and you need to share your screen and then you need to attempt the exam. Okay, your video recording and your screen will be shared and that will be monitored. So those who secure at least a minimum, it's not just to something like uh, reject you, but it's something like a basic assessment to understand how well you understood from what we taught. We are taking these much of efforts, how well you understood, just to assess that. It's not like a filtration. It's just like to assess how can we improve ourselves, how can we make much more better, and to make you understand even more. Okay, so everyone participate in exam. So minimum pass percentage is required for getting the certificate is 40%. So those who secure 40%, for them certificate will be provided. If you opt in for basic template, you will get basic template. No matter you are using basic template or premium template. So I just don't know whether exam will be conducted only for those who opt in for premium template or for both people, both the categories. That thing will be informed by the team. So as far as the information provided, there will be an exam followed by the certification. Certificates will be for basic templates. Certificates will be dispatched immediately in your mail. For premium template, a 1 week processing would be there. We need to verify all your details and background verification check would be there. Then only you will receive the certificates. So now I request anyone to unmute yourself and to share your feedback as uh, our sessions are are about to complete. So anyone, I request your feedback will be recorded right now in the live stream, YouTube live stream. So anyone can unmute yourself and you can tell few things how you understood the today's session and what is the feedback from your end. Okay, I'm just muting myself now. You need to unmute yourself and you need to share your feedback. So I'll call name wise. So we have Inamal. So Inamal, can you please unmute yourself? Inamal, are you there? Inamal? Sikarani, are you there? Okay, Vaibhav, are you there? Vaibhav, Sri Krishna, Vishal. Anyone can share your feedback.
Yes, today's session is you gave a quite a pretty information which we don't know much about, like any of the topic either. And the total course was completely fulfilled with the course. Like even though I don't have any basic idea about the PCB, you led us to explain the designing, and not only covering this the designing aspects, you also led us to focus on the chemical parts, physical part like that. So it's good.
Yeah. So thank you for joining today's session. Hope the session is informative. This is your expert mentor Hemant from Suchna. Signing off. Bye bye.